Now I will discuss with you that what are the uses of this formula, that is the distance formula. So first use that Ed named the distance formula, so it is used to calculate the distance between 2 points. Let us suppose there are 2 points in a plane like this. Coordinates of this situation are 3, 4. Suppose the point A, and another situation is B. Coordinates of this point are 6, 9, or you can say 6, 8. Suppose 3, 4 are the coordinates of the initial position A and coordinates of the point B are 6, 8. How we will find the distance between these 2 points? This is the important question. This is the application of the distance formula. In using the distance formula, one of the situation is taken as x1, y1 and final situation is to be taken as x2, y2. So if we compare it, we will find the x1 is equals to 3 and y1 is equals to 4. That is the x1 and y1 coordinates of the point in the first situation. And coordinates in the second situation B, x2 is equals to 6 and y2 is equals to 8. x1, y1 and x2, y2 are the coordinates of initial and final situation. We want to calculate the distance, or we want to apply the distance formula. What is the rule? What is the formula as discussed with you? That is, if x1, y1 and x2, y2 are the coordinates of a point, then distance between these 2 points is given by root of x2 minus x1 square plus y2 minus y1 square. There should be no confusion in using the formula in another shape also. What is that shape? Distance formula can be used as x1 minus x2 square plus y1 minus y2 square also. There should be no confusion, because in whole square either we say x2 minus x1 whole square or we say x1 minus x2 whole square. Here x2 minus x1 whole square, it is x1 minus x2 whole square, having the same meaning, because a minus b whole square or b minus a whole square are same. A minus b whole square is a square plus b square minus 2ab. B minus a whole square is b square plus a square minus 2ab. Similarly, you always remember writing x2 minus x1 or x1 minus x2 in whole square, having the same result. Similarly, y2 minus y1 whole square or y1 minus y2 whole square. So our question is, we want to calculate the distance between the points A and B whose coordinates are given by 3, 4 and 6, 8. So x1 3, y1 4, x2 6, y2 8, f 3 ordinate 4 in first position, f 6 ordinate 8 in the second situation. So if we find the distance between these 2 points, or you can mention it by AB. AB is equal to distance between these 2 points x2 minus x1, that is 6 minus 3 whole square, plus y1 minus y2 or y2 minus y1, that is 8 minus 4 whole square. And finals square root, as the proof of the distance formula is being told you. 6 minus 3 is the 3, its whole square is 9. 8 minus 4 is 4, its whole square is 16. 16 plus 9 is 25 and its square root is taken as 5. Only plus 5, not negative 5. Why? Because we are calculating the distance, and distance is always supposed to be considered as the positive one. So this is one of the example that how to apply the distance formula, which have been discussed with you, that if coordinates of a point at one end are x1, y1 and other end are x2, y2, x2 minus x1 square plus y2 minus y1 square, or x1 minus x2 square plus y1 minus y2 square. Comparing and knowing what are x1, y1 and x2, y2, putting these values, we can calculate the distance between any 2 points in any situation of the coordinate geometry. Now I was telling you what are the other uses of the distance formula. So other uses are, which will be discussed with you, that to prove that triangle is equilateral, triangle is isosceles, triangle is right angled, quadrilateral is parallelogram, quadrilateral is the square, quadrilateral is rhombus, or area of triangle, area of quadrilateral, or proving the collinearity of the 3 or more points. So these are the other uses of this formula which we will share with you.